Hello guys, welcome back to Surveying Solution, your number one YouTube channel where you get solutions to all your surveying problems. And on today's video we are going to start with the coordinate aspect of our forward computation. We've been able to get our arithmetic sums, we've been able to get our delta nothing and our delta hasting, and so far we've done so much. So if you really need to get some things, just refer to the previous videos where we've explained so many things exhaustively. Now we want to get the uncorrected coordinates for each of the new points that we are established. When I mean new points, I'm talking about points 1 to, let's say, point 4 and subsequently KG21. So now how do we go about it? On our previous video, one of our previous videos rather, I was trying to emphasize on the reason why I left KG22 here. And the reason why I left KG22 here, which is actually, would I say, a way to make the work easier for us, because it can actually be in the middle as well. However, I left it here because since the travel started from KG22, I believe leaving KG22 here will make us to just easily get the coordinates here, apply it to our partial coordinates, then get the uncorrected coordinate, and we move further. So that was one of the reasons why, or that's one of the reasons why, even when I was in school, I used to leave the coordinates of the control where the traverse started at the bottom here. I just do that, and it has been working for me. And you know, I've been telling us that in Surveying Solution, what I give to you is what is the easiest and something that will make you just go over your problem with so much ease. So now let's continue. We have from the field book or from our computation, we've seen so far that we started from what? From KG22. Therefore, we are using the coordinates of what? Of KG22, which is already the coordinates that are here. Now, what do we use them for? We use them on these partial coordinates here, on the partial coordinates of delta northern and delta eastern. So we use the northern and eastern respectively to get the uncorrected coordinates for the new point. So how do we go about it? It will be the corrected coordinate of what? KG22, which is here, plus or minus whatever the sign you have there, this to give you the uncorrected coordinate of the next station. So it is still a cumulative process, the way we did our, what do you call it, our arithmetic sum. So it's still a cumulative process. So the sum you have here, plus or minus that of the next line, will give you for the new line, plus or minus that of the next line will give you for the new line. So that's how we are going to apply it until we get to this point. So now let's get to our calculator. And one other thing again is that please, you just need to get a calculator for yourself. And I told us earlier on that I prefer this calculator, at least one of the least programmable calculator you can use as a surveyor or maybe as a surveying student. There are higher configurations of calculators, but at least for the meantime, this should be the least you should have, and there are other ones anyway. So get a calculator for yourself, and then let's get to work. So we have the coordinate of KG22 as what? The northern coordinate rather as what? 860.181.523. So we apply it to the delta northern of the first line, which is, since it is positive, plus 23.883. Isn't it? Yeah, it is. So we have the first uncorrected coordinate as what? As 860.205.406. So since I told us it's a cumulative process, this our sum here plus 43.711. So what do we have? We have 860.249.117. The next one here is minus, therefore we say minus 204.859. What do we have? We have 860,044.258. The next on the line here is what? 0.660, and it's positive, so we have plus 0.660, sorry, 660. So we have the uncorrected for the next line as 860,044.918. Then the last one here is plus 26.738. We have 860,071.656. So this is the uncorrected coordinate for KG21 we got from our traverse computation. So now let's for the northern coordinate rather. So now let's come to the eastern. We do almost the same thing we did. So we have 600,000.160. That's 60,000. We have 600,000.160. Then plus 202.790. So we have 600,202.950 plus 111.702. So we have 600,314.652 plus 41.149. We have 600,355.801. Then the next one here is minus 249.536. We have 600,106.265. And then finally we have minus 171.087, and then we have 599935.178. So these are the northern and the eastern values of the coordinate of what KG21 we got from our traversing. So remember that KG21 is a control, and since it is a control, it is a point that we already know the coordinate. Therefore, we are going to bring out, or let's say we are going to write the coordinates of this control here. We are going to write them here. So what's the coordinate of this KG21? The coordinate of KG21, the northern coordinate is what? 860,071.644, whereas the eastern value is 599,935.185. So with these values now, we can be able to measure the difference between what we got and what we are supposed to get. Remember, that was the same principle I used to explain for the misclosure in angle when we are starting our forward computation. Good. Now it's the same thing I'm still going to use to explain to how we'll get the correction to our coordinates. Now remember, we are having this, or this is what we are supposed to get, because this is the defined coordinate value for this control here. But what we got from our traversing was this. So what do? We are going to compare these two values. Which is bigger, which is smaller? So now, first of all, let's find their difference. So we have 860,071.656. We have 860,071.644. Since their own numbers are the same, to avoid stress, let's just say we have 0.656 minus 0.644. The reason why I used 0 was because these whole number here are the same for the uncorrected and the corrected. So the stress of typing it out, maybe you are in an exam, or maybe you want to do something very fast or something like that. So since the two values are the same, You can just use, you can assume any value for the first part, and the difference you need is the difference in their decimal. So the difference we have here is what? We have 0.012. When we come to our easting, we also find out that their whole numbers are the same. So let's assume we still have 0.178 minus 0.185. So this is giving us a value in standard form. It's just simply 0.007. Yeah, 0.007 minus 0.007. Now it gave us a negative value, however, which is there. Now let us look at this. We have 656 and we have 644. From the explanation I used previously, I let us understand that you look at what you got and you look at what you are supposed to get. What you got is what? 656. What you are supposed to get is what? 644. So by the time you look at this 656, 656 is bigger than 644. Therefore, for you to move from 656 to 644, it means you have to remove from what? From 656. I hope it is clear. I know so many persons will say just go straight to the point and stuff like that. But the reason why I take time to explain it to this depth is because immediately you make a mistake on the sign and you start distributing the correction with a wrong sign, the coordinate you are going to have subsequently will also be in error. Therefore, you need to understand what the sign is from this point, so that by the time you distribute it up, you will still use the actual or maybe the appropriate sign. So now again, we are supposed to get 644 as a decimal. The reason why I'm not talking about these whole numbers is because they are the same. So let's just consider our decimal here. But if they are not the same, please do not exclude them. Even if they are the same up to 1, make sure you use them so that you don't make a mistake. But for the sake of this particular question, since our own numbers are the same, I just decided to look away. Now we have 656 as what we got, and what we are supposed to get is 644. So to move from 656 to 644, that means we have to remove. I hope you get. Just like you're coming from 10, you got 10, but you're supposed to arrive at 8. So you have to move backward 2 steps to get to 8. So it's the same thing. So we are supposed to get 644, but we got 656. Therefore, the error on this, or the correction to the control here, is minus. So it will be, the sign here will be minus. That is clear now. Please, if you don't understand, you can just rewind and maybe listen again and you'll get it. Now let's come to this. We got 178 and we are supposed to get 185. I don't know if you recall, when we did the subtraction with the first from the second, we add the negative value and whatever it is, but I just did not want to write negative value because I wanted to explain some things to us. Therefore, I did not write it. Now, if you look at it, we got 178 and we are supposed to get what? 185. So what do you do to 178 to get to 185? You add to 178. So how much do you add to 178 to get to 185? Which is this. Therefore, the correction on this station is plus 0.007. I don't know if it is very clear now. It should be very clear because it's very simple. Therefore, the sign here is positive. So when you do 0.178 plus 0.007, you have 0.185. So that's just the idea behind attaching signs to the values here. So I believe it's clear up to this point. Now we want to distribute the error upward. That is where the essence of this is where we now understand why we did our arithmetic sum. So how do we do the distribution of the correction upward? It's still very simple. How do we do the distribution of the correction upwards? It's still very simple. let's get our rough sheet and let's do some things on it. You know, we have an error of 0.012. That's the misclosure we have on the northern aspect of this computation. So how do we go about it? This 0.012 divided by the last arithmetic sum we have for the northern. The last arithmetic sum we have for the northern is 301. The last arithmetic sum we have for the northern is 301. So this 0.012 divided by 301 multiplied by the arithmetic sum for each of the station. So you multiply by the arithmetic sum on station 1, on station 2, on station 3 until you go to your last station. So that's how you distribute the errors on the on the coordinates. Same thing happens for your delta easting. Now the easting misclosure we have here is what? 0.007. So we have something like 0.007, and the last misclosure we have here is 777, which is 777. The last misclosure we have here is 777, which is this, as we've written it down here. So the next thing we are going to do now is we are still going to use the quotient we get from here and then multiply it by the arithmetic sum we get for each of the stations until we get to our last station. So this is just an overview of how we are going to distribute the error upwards. So now let's get back to work. So we still get our calculator, and there is a very simple and short way we can go about it. We need to put our quotient in a particular constant, like on the calculator, maybe saving it in a particular alphabet, so we can just be recalling the alphabet and then multiplying continuously. So we said we are having a misclosure of 0.012 for delta northern, and our last arithmetic sum is 301. So from my explanation, what we are going to do, we'll say minus 0.012 divided by what? By 301, and we have something like this. Now the reason why you are seeing 0.000 there is because we have kept, or we've configured the calculator to 3 decimal place, and the quotient we have there is very small. So now let's move the calculator back to its normal function and let's see the value we are going to have. So we have this. So we have something like 0.00000, like 5 zeros, 3. So what we are going to do is we are going to store this quotient on the calculator as alphabet A. So we say shift, we press this recall button, and then we choose a particular alphabet. Since we say we want to store it on alphabet A, on letter A rather, we press A. So the answer is already on A. So by the time we recall alpha A, the answer comes out. So this is what we are going to use. So we are going to use this to multiply the arithmetic sum for each of the stations. By the time we use to multiply the arithmetic sum of each of the stations, we are going to get the correction we are going to apply to the coordinates on that particular station. So you can see it's very simple. The first thing you are going to do is just get the quotient and save it on your calculator, so you don't have to press that over and again. Isn't that a sheet? I think that's a very good shortcut. So now we've stored it as A. So since we've stored it as A, we are going to be multiplying it by the corresponding arithmetic sum for each station. So how do we go about it? We still come back to our computation sheet. On the computation sheet here, the arithmetic sum for the first station is 24. Therefore, we have A multiplied by 24. So we have A, you edit it, and you multiply it by 24. You have something like this. So, you know, to get ease, like to write it easily, we still have to keep the calculator maybe to 4 decimal place or 3 decimal place. So how do you do that? You press shift mode, it will take you to setup. On the setup, this fix just shows decimal place, so you press 6. It's now asking you how many decimal places you want to leave your answer to. So let's say we are leaving our answers to 4 decimal places. So by the time we configure the setup to 4 decimal places, the product we have there is what is minus 0.001. Let's still put the 0 there. So that's the correction we are going to apply to this coordinate here for station 1. We still do the same thing for the second station. We edit, we remove the 24, we add 68, we multiply it. We have what? Minus 0.027. We come again, we have 273. Therefore, we edit, we multiply by 273, and we have what? Minus 0.0109. We come to the last one, we have 274, we edit, we put in our 274, and we have the same amount of error to, we have 0.0109. So that's how we did it for the northern. So we are going to do the same thing for our eastern. So in this case, we are saving it on the letter B for the eastern. The error for eastern is what? 0.007. So we have 0.007 divided by our last arithmetic sum here is 777. We have 777. So we have this quotient here. Since the values are still small, you still see them as 0.00. So you know what's happening now, as I've explained earlier. So let's say we are going to put it on alphabet B. So recall alphabet B, and you still get your 0.000 because the values are very small, maybe to fifths or whatever decimal there. So now let's multiply it by the arithmetic sum of the first station. The arithmetic sum of the first station here is what? 202. So we have multiplied by 203 rather. We have multiplied by 203. You see that we have a value to write now. We have 0.0018. We come to this one, we multiply it by 315. We have 0.028. We come to this one, we multiply it by 356. We have 0.032. We edit, we multiply it by 606. We have 0.0055. So these are the corrections we are going to apply to the coordinates on each of the stations or on each of the points. So we already have the signs attached to each of the correction. Therefore, we just continue arithmetically to get the corrected. We are going to use our red ink for this process. So now let's go. We have for the first one, we have 860,205.406 minus 0.0010. So we have our difference to be 860,205.405. We come to the next one. We have 860,249.117 minus 0.010. 0027. We have 860,249.114. We come to the next one. We have 860044.258 minus 0.0109. We have 860,044.247. Then for this other one, we have 860,044.918 minus 0.0109. We have 860,044.907. So these are the corrected coordinates for the points, the northern values. Now let's come to the eastern values. It's still the same approach we are going to go about it. So since this is plus, we are going to add everything. So we have 600,202.950 plus 0.0018. So our sum here is what? 600,202.952. The next line we have 600,314.652 plus 0.0028. So we have 600,314.655. We move until we get to this point, which is 600,106.265 plus 0.0055. So we have 600,106.271. So you can see this is very simple. I missed a point here. We have 600,355.801 plus 0.0032. So we have 600,355.804. So you can see that this computation is very simple. This brings us to a very good end, or would I say, this brings us to a very good end of forward computation, or let's say traverse computation. And so far we've been able to share a lot of things, and the videos are there on the channel, which you can always refer to and then give yourself the best explanation you need. So thank you very much for watching this video. Please, if you've not subscribed to the channel, please, I'm begging you, please subscribe, like this video, and invite your friends to come and do the same thing too. On our next video, we are going to take a very big step higher, and we will discuss about blunder. Yes, blunder. I know this is for the advanced diploma classes. Yes, we are going to discuss about blunder. You know, if you go to site and, for instance, you measure a distance or you observe an angle in error at a particular line or a particular point, what do? During computation, you find out that, okay, you've made a mistake, but by the time you carry out the computation up to some point, you would know that, yes, it was on this particular station you made the error. So that on going back to site, you just go back to that particular station and you observe your angle or you measure your distance and you come back and recompute. So on our next video, we are going to discuss how to detect blunder. If there is a blunder on a particular computation, how do you detect the blunder, and how do you know the particular station, either a line or a station? So that will be the content on our next video. Thanks for coming around. Thanks for following the series up to this point. I know you have been able to get so much you need for computation, and then subscribe to the channel. Oh, I've said that, but I just can't help it. I still have to say it again. Yeah, thank you very much. Subscribe, invite your friends to do the same thing. See you on the next video. Until then, make sure you study very hard and make whoever you want to make proud. Make the person proud.